Hi everyone. As you probably heard, there was a major earthquake in Japan on January 1st, 2024, just a few days ago. Current news reports indicate that a total of 73 people have died. There was significant devastation, although it was rather localized to the Noto Peninsula. And in this video, I want to give you an overview of what's happened in Japan, and most importantly, in regard to the theme of this video, is to compare what happened in Japan with how likely other places will be prepared to handle a major earthquake, particularly in the Pacific Northwest and throughout California. Now, as I mentioned, this earthquake was a magnitude 7.6 earthquake that occurred in the Noto Peninsula, 450 miles northwest of Tokyo. There's another view of that location. And as I mentioned, in this localized area at the tip of the peninsula, there was widespread devastation. It looks like some of the two-story buildings where the upper story buildings sheared off and collapsed onto the lower story. Perhaps inadequate shear reinforcement there. And of course, as is common with earthquakes, there's apparent rupture of gas and electrical lines, which starts fires. And a lot of damage that occurs in these earthquakes is from fire damage. Another view of that. This is a view from space, shows the widespread area that's burnt out. There was also a rather small tsunami, 4 foot high, but interestingly, that's the only major tsunami warning that the government of Japan has issued since the 2011 earthquake that generated a tsunami and devastated the Fukushima nuclear plant. Now, the couple takeaways in this video I want to address is, one, Japan as a country is the best prepared to withstand earthquakes and to deal with their aftermath compared to any other country in the world. And yet, to have this type of damage and this number of deaths suggests that other countries have a long way to go to prevent utterly catastrophic damage and loss of life. So this is a photo I showed earlier of this building laying on its side. It suggests a bearing capacity failure, probably due to liquefaction of the underlying sandy soil foundations. We saw that in 1989 in the Loma Prieta earthquake in the Mission District, where liquefaction caused buildings to collapse. Here's some footage of the earthquake while it occurred in this area of Japan. Again, widespread fires. Japan undoubtedly has one of the best responses to these types of disasters. See buckling of the roadway, another collapsed house. So Japan has been one of the leading countries when it comes to earthquake research, and in terms of implementing that research into updated design and building codes. And yet they still had a number of buildings that collapsed and other buildings that were burned out by fire. So how well would the United States be prepared to handle a magnitude 7.6 or greater earthquake? You know, if you look at the risk along the San Andreas Fault or the Cascadia subduction zone, those expected major earthquakes are in excess of 8.0. So almost 10 times greater than the earthquake that just occurred here in Japan. And as I've mentioned in previous videos, the U.S. has its work cut out for it just in terms of keeping up with maintenance of existing bridges. Just a year ago, you had this bridge collapse near Pittsburgh. In fact, I think President Biden was visiting the area, and this happened while he was there. And of course, we see the recent closure of I-195 in Providence, Rhode Island, where they discovered in a recent inspection, well, actually, it wasn't the inspection that uncovered it. It was a junior engineer who was doing work nearby that noticed something going on with the bridge deck moving excessively, and upon further investigation, noticed a broken anchor bolt. You've got that situation. You've got exposed rebar from deteriorating concrete and rebar itself. So many of our bridges are past their design life of 50 to 60 years, and many of them have not been very well maintained under static load conditions, let alone additional loading imposed by an earthquake. Now, I mentioned the San Andreas Fault, which poses a significant seismic hazard to Los Angeles and San Francisco. In San Francisco, again, widespread devastation from the earthquake in 1906. And again, most of that damage was caused by fires. Here's an article that mentions that in the San Francisco area, they expect upwards of 7,800 deaths and $98 billion in property destruction as a result of a major earthquake. And I expect those numbers could be underestimated, actually. I mentioned the Cascadia subduction zone. Recently, it was discovered that the federal government had not updated the tsunami hazard for the northwest part of the United States. So there's not as much funding available for warning systems. Japan has an extensive tsunami warning system in place, and they evacuated several thousand people from areas that could potentially have been impacted by a major tsunami wave. So I mentioned Japanese design standards. Most of my work is associated with construction phase testing of bridge foundations, and I had occasion to do pile testing during construction of a bridge in southeastern Missouri. It's very close to the New Madrid Fault. Many of you are aware that one of the largest earthquakes recorded in North America occurred in 1811 and 1812, where the Mississippi actually flowed backwards for some period of time after the earthquake. And this bridge project I was on, it was apparent to me that the designers had a mistake in terms of the required pile lengths. I thought they were far too shallow just for the static loading. Turned out I was right. They had to double the pile lengths as I had anticipated. But the original design for these piling had a net embedment of 27 feet in the foundation soils that consisted of saturated sands with SPT blow count of 15 blows per foot, which is at the low end of the medium depth range. So highly susceptible to seismically induced liquefaction. So it wasn't my job to review their design, but I felt compelled as an engineer to ask the question of the DOT through the contractor I was working with, hey, what gives with this design? There's no way it can hold up during an earthquake. And they informed us that, they didn't intend for it to, that they expend more money on major arteries, major highways, particularly interstates, to make sure that they can maintain traffic flow, and they're prepared to let these other bridges fail in the event of an earthquake. And that just blew me away, because the incremental cost, in this case, to install the foundations to a depth that could withstand seismically induced liquefaction was a very small incremental cost. And it reminds me of the situation in Canada, I think 25 years ago, where they had a major ice storm and it took out transmission line towers, and the foundation was able to be reused. So it seems to me rather short-sighted to design a bridge where you could expect the foundation to fail in the event of a probable earthquake in the life of the bridge. So, in engineering, you're balancing needs and costs, but again, this is a life safety issue and it's a policy issue. And I think it's not exactly a sustainable approach to essentially do designs where you have to start all over again to replace the bridge, the superstructure, and the foundation. Something I think would be far more sustainable would be design all foundations to survive the design earthquake loading. And then if you had problems with the superstructure, you could address it in a far more expedient fashion than if you have to start from square one and replace the foundations and move up from there. And as a reminder of how active this area of New Madrid was and will be again, this area is largely agricultural. So you have fields where you see these lightly colored areas. Those are old sand boils from the 1812 earthquake. So what happens is the ground shaking from the earthquake causes the water pressure in the soil to build up, and it reduces the friction, the contact stress between grains of soil. And when you reduce this friction between particles of the sand, you have less resisting the loads from a pile foundation or a shallow mat foundation or spread footing. And these pore pressures increase rather quickly and will seek the path of least resistance and shoot up as geysers in many cases from the surface of the ground, tens of feet. And that's what happened here. And of course, these geysers were taking particles of sand with them and deposited it on the clayey surface soils. So here you are over 200 years later seeing clear evidence of what's going to happen in this area. And within a mile of seeing fields like this, they're building a bridge where the foundation couldn't possibly withstand this type of earthquake loading. So I think this earthquake in Japan should serve as a cautionary tale to people in the United States and in other countries that we really need to take these seismic hazards seriously and not design from an optimistic standpoint, and certainly from a standpoint of government policy. I think more needs to be looked at in terms of sustainability. You know, when, not if, a major earthquake occurs in California, either San Francisco or Los Angeles, you're going to have widespread building damage. And it's going to take as many structural engineers that can get out there to assess these buildings to determine whether they could continue to be safe for occupancy. So I don't know what California has worked out in terms of their earthquake preparedness or aftermath, in terms of getting teams of engineers in there to evaluate these buildings in an expeditious fashion. My gut tells me there's not nearly enough engineers that could be brought to bear in a timely fashion to properly evaluate the safety of such buildings. So I want to give a shout out to channel members. I really appreciate your support. Also a shout out to those of you who have provided super thanks. All this goes to supporting the channel and enables me to continue posting at least weekly on broad civil engineering, geotechnical, and even geology topics, as well as breaking news stories in those related fields. Also, I want to thank you to those of you who have subscribed and liked these videos and left a comment. Also, if you want to check out a link in the description, I have a free digital download of the top civil engineering disasters of the past 100 years. Thanks for watching, everyone.